had finished the D family, okay, and we had finished the R family correlation. This is what we had finished. So effect size per se, we have finished. Now I told you that, just a second. I told you that the next thing that we have to do is that, so we have finished SLR, we have finished effect size, and the next thing that we have to do is heterogeneity. Okay, so what I'm going to explain to you now, I hope all of you can see my slides. What I'm going to explain to you today is heterogeneity in data. So as I said, we just don't finish at saying that, okay, this is the consolidated effect size and I've done my meta-analysis and it's over. We don't stop there. What we do is that we try to further narrate data or further understand the data. And one parameter that we try to understand is heterogeneity. Heterogeneity, according to Higgins, is what we call as statistical heterogeneity, and it is inevitable. So let me tell you that all these papers that I showed you yesterday, so I showed you this Excel sheet. Okay, this Excel sheet we were working on yesterday. Okay, now all these papers that I have, collected, okay, all these papers that I have collected, they are papers which are from different domains. So they are from different locations, they are from different, data sets, different samples, different methods of analysis also. Okay, some places I got correlation, some places I got regression, beta coefficient. So they are from different domains. Now, because they are from different domains, this means that they will be heterogeneous. There will be some variance in them. There will be some heterogeneity in them. Okay, that is very well understood. So Higgins says that heterogeneity in meta-analysis is inevitable. Okay, so a very high heterogeneity could mean that the studies have nothing in common and there is no real effect size. Just a second. Just a second. So when I say heterogeneity, a very highly heterogeneous, it means that the studies have nothing in common and there's no real true effect behind them. So here the whole purpose of studying this is that will this heterogeneity lead to a change in the effect size? Now, what do I mean by effect size? Here I'm referring to the consolidated effect size. Okay, here I'm referring to the consolidated overall effect size. That is what I'm referring to. Now, homogeneous and heterogeneous data. So what does the homogeneous data look like? Okay. Homogeneous data looks like this. So in homogeneous data, what happens is that you have all red apples. So everything is very, very similar. A purely heterogeneous data would mean that you have apples and oranges and guavas. This is again what we don't want. What we want in the data set is that there should be all apples and of different colors. So if I put this technically, if we are talking about one topic, for example, social media technology use, this is my topic. What I want is that they should be all apples. When I say they should be all apples means all the papers that I have collected, 40 to 60 paper for meta-analysis, should be on social media technology use, should talk about only social media technology use. Okay. When I say apples have different colors, which means different locations, maybe different research methods, maybe different samples, so that will do. Okay, but they should be apples. They, if you are saying social media technology use, it should be social media technology use. Or like in one of the sessions, I think in the first session there was a question. He said, the gentleman said that I am working on emotional brand image, something like this. Okay, so can I take only brand image? So yes, you can take papers where there is only brand image or emotional brand image or sentimental brand image. So till the time the variable is brand image, which means apples, you can take variations. Okay, I'll explain one more paper to you. So when I was making this paper on, there's one paper which is under review on meta-analysis, which is religiosity religiosity and its impact on purchase intention. So I'm doing a meta-analysis on that because I got a lot of papers, somewhere around 48 papers I got, where religiosity and purchase intention correlation, beta coefficient, etc. was available. So I did a paper on that. But the problem was that should I take only the word religiosity, or should I take papers like religious belief, religion, okay, religious inclination? So I did take these four words. I did get heterogeneous data, but when you take these four words, when I say I'm taking religiosity, religious beliefs, religious values, okay, religion, in different papers, that variable has been given different names. So I'm picking up all of these four categories of, say, papers. In that case, you have to give a small justification through definition that these four things are almost the same thing. So religious beliefs, religious values, religiosity, religion, okay, religious inclination, these five terms I picked up from papers, but then I gave definitions and I said they are actually meaning the same thing, or they are basically listing the impact of religion on the consumer. Thus I am taking five different things. But in any case, when we take, the variables are different, the location is different, there are so many differences in paper, heterogeneity will be there, it's inevitable. But I want all apples, please. So all papers on religion, religiosity, it will do. There's another variable which says spirituality. Spirituality is different from religiosity. Okay, so that, sorry, I missed the PPT. So that I can't take. That I can't take. Okay, just a minute. Okay, so that I can't take. So this is about religiosity. Now, how do you check religiosity? So we have to check religiosity and we have to do something about it, or we have to at least report it. So here the purpose is not to remove religiosity. Here the purpose is to remove it. Okay. So for removing it, what do? I make, first thing I do is I judge heterogeneity of my papers through a forest plot. So heterogeneity can be judged by a forest plot. You know what is a forest plot by now. It came in Excel sheet also. Okay. Now, how do I judge heterogeneity through a forest plot? This is called an eyeball test. It's a very, very preliminary test. Okay. And it is a test which is not full-fledged. But this is one of the methods of judging heterogeneity, although not a concrete one, and we don't even sometimes report it, but you should know it. Now, in this forest plot, you see this green color ball, which is something called a mean. Okay. And you see values going helter-skelter. So when I say there are values to the left and there's values to the right, so the values are just, left and right. Okay. And they're not in a single line. Okay, so had they been homogeneous in the context of their effect sizes, respective effect sizes, so individual studies, power or effect sizes, they would have been in a straight line, either towards the right or towards the left or towards the center. But here you see that these 12 studies are helter-skelter, they are left and right. So from an eyeball test, I can say that these studies are heterogeneous, or this pattern of data set is heterogeneous, it's not homogeneous. This is one method of finding out heterogeneity, number one. What is the second method, or a more concrete method, is the Q value. When I showed you the sample paper yesterday, there were two columns in that sample paper, which I told you I'll be taking in today, which is the Q and the I square. Two values. Now Q value is supposed to be a chi-square test, and it is a chi-square statistic test, okay, with a set of number of studies which is called K. I showed it to you in the paper also. K means number of studies, and the degree of freedom, which is K minus 1. Okay. The value that is to be assessed over here is the P value. Okay, so the Q value will give you the Q test will give you a Q value, which is not that important. Okay, but what is important is the P value of the Q test. Now, how do you analyze that P value? And we are going to go to the meta essentials also once I explain to you the Q and I. We'll then go to meta essentials and I'll explain there, and then we'll go to the sample paper also. How do you report it? So the statistically significant, the P value has to be statistically significant if the data is heterogeneous. So if the P value is below 0.1 or say 0.05, then you can say that your data is heterogeneous. If the p-value is non-significant meaning if it is more than 0.1 or 0.05, whichever parameter you are taking, then we will say the data is homogeneous. Now, why I'm saying whichever parameter you are taking is because in some papers, the significance is reported as 0.05. In some papers, significance is reported as 0.1. Okay, so different papers have different methods of reporting significance. Okay, so whichever method you take, I'm not saying that any one method is wrong, but whichever method you take, you are supposed to be writing an author to it. So if you say that you're reporting a significance of 0.05, you need an author for that. If you say you're reporting a significance of 0.1, you need an author for that. And both the values are correct. Both the values are correct. There are further some authors in significance. See, p-value is there everywhere. It's there in a t-test, it's there in a chi-square test, not only in meta-analysis, even in any bivariate statistical analysis, p-value is definitely there. Okay. So in significance, you could, even in meta-analysis, if you want, you can also note the significance as 0.01. So that's 99% confidence in, level. So 0.01 means that anything which is below 0.01 is significant or heterogeneous, and anything which is above 0.01 is homogeneous or non-significant. So whichever value you take as a parameter, the p-value will tell you whether your study is heterogeneous or homogeneous. Now, this was a very good method which was being used in clinical study or medical study also. But the problem in this method is that it only tells you whether the data is heterogeneous or it is homogeneous. What it doesn't tell you is the amount of heterogeneity or the amount of homogeneity. Now, this was a problem in clinical studies because even if the heterogeneity in data in clinical studies was barely 1%, the Q value used to come significant. So, I it's almost like saying it's insignificant. So if my heterogeneity is barely 1%, it's almost like no heterogeneity. But because the p-value comes significant, so I will have to write in my report that my study is heterogeneous. So that was a very big problem, especially for the clinical studies, where it was a wrong method of reporting because 1% is almost no heterogeneity at all. So they needed a statistical measure in meta-analysis to quantify this heterogeneity, and that is when another value called I-square came into consideration. So I-square is a method of quantifying the inconsistency across studies. Inconsistency means heterogeneity across studies. So here we try to assess the impact of heterogeneity on meta-analysis. I-square is a percentage. It's the real variation across the study. It's the percentage of variation across the study. And because it's expressed in a percentage, thus it quantifies the heterogeneity parameter. So how do you assess once you get a percentage, once you get an I-square percentage, how do you assess or interpret I-square is that if the I square is 25% or somewhere near it, we will say there is low heterogeneity. If the I square is 50%, we would say there is moderate heterogeneity. If the I square is 75% or above, we will say there is substantial heterogeneity as per Higgins 2003. Now you might say that, ma'am, if heterogeneity comes over 75%, then what do we do? So the best part of meta-analysis is that you don't do anything. If your data collection part is correct, so if your chapter number 2, where we did methods, data collection, inclusion, exclusion principles, Prisma, if that part has been done correctly, whatever statistical results you are getting, be it effect size, be it Q value, be it I square value, any statistical value that you get is correct, and you will not fiddle with it. You will just report it as it is, because this is not primary data collection. It's not that I've got a wrong heterogeneity value. Now I have to go and collect data again because that was primary data, and probably the people were, not whatever you say, not capable, X, Y, Z, whatever, or they were not genuine people, whatever the case might be. Okay, so nothing of that sort is there over here. Whatever heterogeneity value you get reported. In my papers also, I have got heterogeneity value of 90% and above, and I have reported it. Okay, so I'll tell you, I can give you an example of one published paper. Let me see if I can get through it. Give me 1 minute. I'll show you one of my published paper. It just got accepted this month. It's on meta-analysis, and it's got accepted in a good journal, ABDC Scopus journal, by the name of InterScience. So just give me 1 minute. I would like to show you that paper just to prove that. Okay, do we have it? Yeah. So it's yet to be published. It will be published in 23. I just got an acceptance for this. Just give me 1 minute. I'm just opening and showing it to you. Exact point only because yeah. So I'm sorry, I can't send this paper because it is under publication. So 23 it will be published, although we've got an acceptance from InterScience Journal. Now look at this. This is an actual table of my paper, and which is getting published in an ABDC and Scopus journal of InterScience. And look at the heterogeneity values. Can all of you see? Is the word file visible?
Yes, ma'am.
Yes, ma'am. Visible? Yes. So this is a published paper, published in InterScience. I've got an acceptance for it. And I have reported values which are 90% and above. Okay. So the point I'm trying to drive in, the point that I'm trying to drive in over here is that when you get the values that you get, now look at the Q values, okay, or look at the significance value. Most of the values were significant, okay. The I squares were above 90 to 95%. Basically, what I'm trying to say is, don't fiddle with data. This is secondary data. This is not my fault. It's not that I went to the wrong sample or my sample wasn't serious and I have to redo everything. No, if your inclusion principles are well defined, which were well defined in this paper, so these are the, so see, these are the inclusion criteria and exclusion criteria. I've very categorically defined that this is what it was. Okay, so if this is what it was actually, then there is just no problem in defining in heterogeneity. Okay, so this is the this is the journal in which it has got uh, published with another author, Rajesh who's working with me. So it's got published um, in an interscience. It will be published in 23. So basically what I'm trying to say is that I'll just share my PPT again. So, sorry. Oh, just a second. Something wrong with sharing. Share screen. Coming again and again. Okay, give me 1 minute. Yeah. So now I think you can see the PPT. And for the heck of formula, if you really want to know from where heterogeneity is being calculated, these are the formulas. Okay, and now let me go back to the meta essentials where we were working. So this is my sheet number 5, meta essentials correlation data that I was working with yesterday. We had come to the forest plot sheet and we are still on that for heterogeneity also. So just look at the, if you go a little lower, you'll see these values. I'm highlighting them for you. I hope all of you have found it. This is called heterogeneity. These are the heterogeneity values. Okay, so you have a Q value which has almost no relevance except for the fact that it should not be 0 if the data is heterogeneous. There's a P value which is 0.000, which means it's the value is significant, which is because it's less than 0.05. There's an I square which is 95%. Okay, in my data, this is my actual data. So if you remember, we were working on urge to buy data since yesterday. My original data urge to buy, which is in the review process. So there is a very high heterogeneity, significant heterogeneity in the data. Okay, so these are the 3 values that you have to report. There might be many n number of other values that are given. For example, the Z value is there. If you want to report, you can report. So I told you yesterday that the correlation is converted into the Fisher Z and back to correlation. So if you want to report the Z value, you can. But otherwise, heterogeneity, the most prominent values that you have to report in a paper are these. And I've always seen these being reported: the Q, the P, and the I square. Now let's come to the sample paper that I was showing you yesterday. Once my paper is published, it will take time, 2003, then I can start making my paper as a sample paper. But right now I use this paper. So this is the paper I was showing you. I hope now it is clear when we say the Q. Okay, so there's a value of Q and there's a triple asterisk. So the asterisk shows that the P value is significant, and there's an I square, of course, which in this published paper also is way above 90% for all the bivariate, analysis. So right now we have done this whole exercise only for one bivariate. In this paper, it is attitude intention. In my paper, it was urge to buy and perceived enjoyment that I have been working upon since yesterday. You have to do this whole process for all the bivariates that you list. So in one of the papers that I'm doing right now, in which the data collection and consolidation on Excel has taken me 4 months. Okay, so they are huge. They're like 95 papers and they're going to be at least 120 relationships. For all those 120 relationships, I'll have to do this process again and again. So that's an exorbitant amount of, you can imagine the extent of study. When it is a meta-analytical study, you can imagine how big are the results vis-a-vis a single research paper, correct? So that's about heterogeneity. Now I'm left with one more topic, which is called the random effect. So I had told you yesterday when we went to Meta Essentials, I told you yesterday when we were at Meta Essentials that, there's something called a fixed effect model and a random model. So when you go to a fixed effect model, here the effect size is minus 0.36. And when I change this into a random, if I drop down into a random, it has changed to minus 0.42. Now in Meta Essentials, you are being shown 2 types of effect sizes. One is the mixed one, one is the fixed one, and one is the random one. And uh, in case something like this, fixed and random, so you cannot decide which one to take. So for that, I'll have to take you back to a concept of fixed and random model. Try to understand this more like a comical a courtroom drama, where this clown that you see, with all due respect, is the researcher, the meta-analyst, and these two people that you see are actually people who are fighting for an effect size to be accepted. So on the left side we have Mr. Fixed, who says that this data, or the summary of data set, should take into account the fixed effect size, and on the right side we have Miss Random, who says that no, with this data set you should be considering the random effect size. So there's a debate going on between both of them, where they're fighting for this one effect size. So there's a debate going on between these two, and the poor researcher, is the one who has to decide whether I go for fixed or whether I go for random. So let this be like a courtroom drama. So let me explain this diagrammatically first to you. So what does Mr. Fix say? Mr. Fix says that all these studies, these 7 studies that I took up for urge to buy and perceived effectiveness, it says that once I have calculated the consolidated effect size, which over here is theta, okay, you can see on the left side, you can see a triangle. Now this is called theta. Okay, so this is the combined effect size. Combined effect size meaning, let me go back to the meta-analytical sheet. Combined effect size meaning this. Okay, let me, if it's for fixed, I will say this is fixed. So he says minus 0.36. This fixed effect size, Mr. Fix says this is the effect size for all the studies. So he says whatever effect size you had taken for different studies, okay, which was variant. So some had 0.2, some had 0.3, some had 0.4, some had 0.5. So Mr. Fix says that now that we have a consolidated effect size minus 0.36, this will be considered as an effect size for all the studies that we had taken. Okay. Now you might say, why is this assumption being taken? Because very clearly we had got from one paper the correlation of those two variables were 0.3, from another paper it was 0.4, from another paper it was 0.5. So how can he say that all are same and equal to the combined effect size? Why is Mr. Fix saying so? So the reason why Mr. Fixed is making that assumption is, he says these variants that you are seeing in different effect size. So when I mean variance, what he's trying to say is, no, I'll open the correlation one. Here it is. So if this is the consolidated effect size of 0.35, he says this variation that you see in correlation, he's saying this variation. He's saying this variation, 0.3, 0.37, 0.5, 0.4, 0.17, this variation that you're seeing, Mr. Fix says this is only because of chance or because of sampling error. What is sampling error? Many a times when a PhD scholar works on a sample of 200 and 300 and works on any, whether it's a bivariate analysis or whether it's structural equational modeling, and he comes to me and he says that, ma'am, my results are not significant, or my reliability is not coming right, or my SEM model is not working. The first thing we tell him is that check the reliability, which means check whether your sample was genuine or not. If he checks the reliability and the reliability Cronbach alpha is correct, then why is the model not working? So, the structural equational model has to work with a set of parameters of values. So what we tell him is, don't worry, increase your sample size. If you had done this research on 250 sample size, increase your sample size to 500, 600, and the model will start working. 90% times when I tell my students this and they double their sample size, of course, the 250 initial should be reliable. When they double their sample size, their model runs. Okay, 90% times when they double the sample size, their model runs. That is the reason that the sample number is a very, very crucial factor in normal studies also for precision and in meta-analysis also for precision. So Mr. Fixed feels that it is the sample size which is the culprit. He says that these variations that are coming 0.3, 0.5, 0.6, etc. are because of the sample size. And like I did with the PhD student, if you increase the sample size to an exorbitant amount, say 1,000 samples, if all these studies that you have taken, these 7 studies that I've taken between urge to buy and perceived enjoyment, if all these authors had increased their sample size to about 1,000, the effect size of each study or the correlation value of each study would have become common, would have become one value. And what is that value? That value is the consolidated effect size, which over here is 0.33. Okay, this is what Mr. Fix says. On the other side, Miss Random has another debate. She says no. Look at the diagram of Miss Random. She says no. Although there is a combined effect size which Miss Random is calling mu. So you see that triangle which says mu. She says the combined effect size is mu, but these studies which I have consolidated, theta 1, 2, 3, etc., they have their genuine or true effect size. True effect size is a very, very important term in meta-analysis. So Miss Random says that this variation that I'm seeing in different studies for correlation or whichever effect size you are picking up, 0.3, 0.5, 0.6, etc. She says this is genuine. This is true. This is actually true. So this variance is actually true. It's a true effect size. And this variation should remain in studies. And if you double the sample size also, this variation will not go. This is the debate of Miss Random. Now, Mr. Fixed is not convinced. He said, no, ma'am. He says, no. This is sampling error. Sample size is the most important thing in the data set that we have collected. So we should assign the weightage to each and every study on the basis of sample size. Higher the sample size, more the weightage given to each study. And this is something I had shown you in meta-analysis study even yesterday. If you see over here, if you come to the weightages, look at the weightages. I'll just switch to fixed. I'm now on fixed. My effect size is 0.33. Look at the weightages. Okay. So I had shown you yesterday that study number 5 had the highest weightage because its sample size was the highest. On the contrary, study number 4 has been given the least weightage, that is 6%, because its sample size was smallest. And where was this happening? This is happening in the fixed effect model assumptions. So, Mr. Fix says that I will assign weights on the basis of sample size. More the sample size, more precise is the study, and thus I will assign more weightage to the sample which is larger. Okay. Whereas Miss Random says no. The variation that is coming in these studies, or the variation of effect size or correlations that is coming in this study, is not coming because of sample size, although I will assign some amount of weightage of sample to the study, but I will also give weightage because of other factors. Okay, these other factors are difference in location, difference in sample as in some are retail managers, some are students, sample that ways, the characteristics of the sample, difference in research methods, okay, difference in environment, setup of research. So I will not only base my weightage on sampling, I will base my weightage on other factors also. These other factors are statistically known as tau. I'll explain what tau is, but these other factors, which Miss Random says it's not only sampling on which I'm going to give weightage, I am going to give the weightage on some other factors also. These other factors are something that we call statistically as tau. So when I go back to my meta-analytical sheet, okay, and I change the fixed model to random model. Now I've changed it to random model. So now what happens is that my weightages are almost similar. 13, 14, 14, 13, 14, 13. Why? Because the weightage which has been assigned to this study, and I'll show you an Excel sheet of Kaushik sir also of how it is done. The weightages that are assigned to these studies are not only on the basis of sample. Had they been on the basis of sample, study number 5 would have got again 24% weightage highest, and study number 4 would have again got 6% weightage, which is least. But Miss Random says that no, I am not only assigning my weightages on the basis of sample, I am also assigning it on the other factors, differences in research methods, differences in sample type, differences in location, differences in analysis. And that statistical portion that she's taken into consideration is tau, because of which her weightages assigned to different studies are different from the fixed model per se. Okay, so this is what Miss Random is saying. Now let's come to the total differences. Now if you've understood the point of what the debate is in this courtroom, now I can differentiate between the fixed and the random model. So fixed effect model assumes one true effect size for all studies. It says that the combined effect size is the actual true effect size for all studies. This variation correlations that you're picking up is pseudo. Okay. Random says no. All studies do not have one true effect size, but there is a distribution of true effect size in all the studies. And they are real. They are not pseudo. The fixed effect model assumes that all studies, along with their effect sizes, which of course he says is same as the combined effect size, are coming from a homogeneous population of research papers. Whereas Miss Random says, and this is as per Borenstein 2011, the fixed model says that all these studies and their effect sizes are coming from a heterogeneous population of research papers. These are assumptions of both the models. The fixed model says to calculate an overall effect size, which is our combined effect size. Even the formula of calculating the combined effect size for both these people is different. That's why you are getting two different combined effect size in the Excel sheet when you press fixed and when you press random. So fixed says, when I will calculate the overall effect size, I will give greater weightage to the greater sample. Miss Random says that when I calculate the overall effect size, okay, I will not give the greatest weightage to the greatest sample. Okay. Fixed effect says I will take into consideration, while calculating effect size, I will take into consideration only the sampling error. What is the sampling error? I've explained to you. Okay. He says that the sample, when they become 1,000, all these studies will have the same effect size. That is what is called sampling error. It is also called error by chance. Okay. So he says that while I'm calculating this effect size, I will only take into consideration the sampling error, and this sampling error is also known as within studies error. Okay. But Miss Random says no. I am going to take into consideration the sampling error or the within study error, but I will also take into consideration the other errors like research method, treatment, type of population, etc. And she names these other errors as between study errors, in whose calculation she takes a statistical value called tau. Okay, so where fixed effect says I will only take within study errors, random effect says I will take into consideration within and between study errors. Okay, within study, sampling by chance error, between study, other errors like research method, treatment, etc. Uh, okay, so that explains this. Now let me show it to you how this is manually done. So although I have the formulas, these are the formulas of fixed effect. Okay, so these are a little different from the formulas of random effect. Okay, random effect, there comes a value called tau. So this is the value tau. Okay, tau square is calculated by q minus degree of freedom, okay, which is k minus 1, as I told you in q, divided by c. Okay, so I'll explain this I'll explain the difference in the calculation of fixed model and random effects model in a little better way, and this I can do thanks to again Kaushik sir, who actually has opened these calculations and put them up in an Excel sheet, and this comes from his YouTube videos. This sheet I have made from his YouTube videos. So the what you see in the red is the formula. This is something that I've added to that sheet of Kaushik sir. Okay, so this is something that I've added, and here you see this is the correlation values that he's taken. This is the sample size he's taken. We have to input like any other sheet. In this Excel sheet also we have to input only these two values. Okay, but what Kaushik sir has done is he's made this elaborated Excel sheet with formulas where he has first calculated the Fisher Z. Okay, he's calculated the Fisher Z of each value of each study. Okay, elaborately. I have just added the formula. So I've just told you on the top that when you convert R to Fisher Z, this is the formula, which is log of 1 plus R upon 1 minus R. Here R is the Pearson correlation value. Then we have the weightage as weight assigned. Okay, not the percentage of weight, the actual weight assigned, which is n minus 3. Here n is the sample size. So if my sample size is 40 over here, my weight becomes n minus 3, which is 37. Then there is a variance calculated, which is 1 by W, that is weight. So 1 by 37 is 0.027. Similarly, we calculate the percentage of weight. Okay, and then further on all these manual calculations, you come to a random effect size, which is 0.3584. Okay, sir has also been kind enough to calculate the value of tau square. Okay, like I showed you, the way I showed you, okay, which is 0.082. Okay, and now this tau value comes into calculations of the random model. So let me go to the calculations of the random model. In random model, where does the difference come? The difference comes over here. The difference comes over here. So in this column, if you see, I'll just show you both the columns. So when you're assigning weights to a fixed model, you are only taking into consideration the sample size, because the 37 value, from where did it come? It is n minus 3. So sample size 40 minus 3. So in this formula of calculation of weights, what have you done? You have taken into consideration only sample size. 40 minus 1. So if the sample size is bigger, 400, 400 minus 3, your weight is 397. If your sample size is very, very small, 25, 25 minus 3, your weight is 22. So your weight is dependent on sample size. This is why in the Excel sheet also that I showed you, the higher the sample size, the higher the weight is attached to a particular study in a fixed effect model. But when we come to the weight formula of random model, the formula is 1 upon V plus tau square. Here V is the variance, and you must be thinking why again and again I have shown the formula of calculating variance. This was the reason that even in the PPTs or even in this sheet, I have shown you the formula of variance, because uh, the variance becomes a part of the calculation of weight when we take a random model. Okay, so here it's taken variance. Remember that assumption of random model which said that all the studies in this data set are heterogeneous. Remember that assumption which was there in random? There was one line in random which said that these studies are heterogeneous. Vis-a-vis that, fixed had said all studies are homogeneous. Now, because random is saying that all the studies are actually heterogeneous, it is taking variance into its formula, because the assumption is that all the studies are heterogeneous. Another thing that it is taking into the formula is tau square. So weightages in random are dependent on what? It is dependent on V, which is variance, because it is assuming that the data is heterogeneous, and tau square because it is taking into consideration the between study error also. What was between study error? The error that has come in, or the heterogeneity that has come into the data, because we have taken different research methods, population, locations, etc. So tau square and V have been taken into the weightages of random model. Thus the weightage changes from a fixed model. And because the weightage changes from the fixed model, the further calculations, which of course take weightage. So see, everywhere you have a W. Everywhere you have a W. Everywhere. So if there's a W everywhere, obviously the final effect size changes to 0.48 thanks to the calculation of the weights on the basis of V variance and the tau square together. Okay, this you can I will be sending you the sheet. You can go through this. Okay, this very categorically explains everything. And if you want to, I mean, everybody is not interested in it, but if you really are interested in it, you can go forward and see it. Now there's one more thing that I would like to complete with you. Okay, so I have one more thing I have to complete with you, and I have time to do so also. I'm closing the other sheets. They're causing a lot of confusion. Just a minute. Okay, this sheet also I don't think I need now. Okay, so this is the sheet now that I have. These values I have told you. There's one value that I want to talk about, which is the publication bias. Okay, I want you to just quickly, we'll go through what is publication bias, because this is very, very important. Again, in the publication bias also, you'll get something called a fixed effect. And if you can all go to the publication bias sheet. You can all go to in Meta Essentials in the sheet number 5, Meta Essentials for correlational data. You can all go to the publication bias analysis sheets, and there's a fixed model, and you can convert this into random if you want to know for random. Acha, by the way, the debate that I was doing with fixed and random, primarily the end of that debate is that if your data, if there is a lot of variance, where do you see variance, or where do you see the true variance, or where do you see the between study variance? Your I square value is the value that shows you between study variance. Your I square is the value of heterogeneity which shows you between study variance. If your I square is above 75%, which is high heterogeneity, you should be going for the random effect calculation. And if your I square is somewhere around 25% or below, which is low heterogeneity, which means you're assuming homogeneity, then you should go for the fixed effect model. That is the relevance of this whole discussion of fixed versus random. Okay. Now, yeah, so I want to do with you in publication bias analysis, what I want to do with you is this one test of publication bias. Okay, so it is called the fail and safe end test, which was given by Rosenthal 1979. So to explain these values, I'll just, or what are these values and how do you interpret them, I'll quickly go to my uh, publication bias. There are too many publication bias methods which can be used. Okay, what is a publication bias? Publication bias is a substantial problem of credibility in research, which can happen because of non-existence of effect. So let me put it in a very very simple language. If at any place while collecting data you have been biased, either you have been biased to take only studies of A category journals, or you have been biased in taking articles which are past 5 years, or sometimes we are biased on the basis of authors citations. So I'll quickly show you all the biases. Sometimes we are biased towards taking only non-significant, we neglect non-significant studies. So if there's an attitude and purchase intention relationship and it's significant, I'll pick it up. In another paper, data set that I'm collecting, initial data set that I'm collecting, if the relationship is non-significant, I remove it, I neglect it. In meta-analysis, you are supposed to be reporting the significant and non-significant relationships of the two bivariate constructs. Sample size. Sometimes there's a bias because of sample size. I feel if I take all the papers which are above 500, sample size, it is good. No, you have to take papers of all sample size. So even if there's a research that you get which has barely 100 samples, you're supposed to be taking it. Don't be biased and pick up, be selective or include only those papers which have a higher sample size. In the inclusion and exclusion principles, never ever in any A category paper have I seen that I collected papers only which had a sample size above 500. I've never seen this selection criteria in any of the A category papers. Unpublished versus working papers, of course, this bias is there, but I have seen people reporting it. For example, in the SLR paper that we saw yesterday, the person very categorically had said that I've only taken academic published papers. So he said, I've not taken dissertation, no conference proceeding, no white papers, no nothing. I have only taken academically published paper. Despite the fact that you can make this declaration in your paper, but it's always good to include published and unpublished papers, because that is what finally removes the bias. Meta-analysis says that any study and any value that has been reported is to be taken, irrespective of whether it's a published paper or a non-published paper or an A category paper or a C category paper. Language bias. We leave out papers which are non-English. But remember, they are papers. Remember, they are data sets. We are leaving them out. They are reported statistical value. Again, this is one bias which does come, and we can write it as a limitation at the end of the study. Okay, we can say that this is a limitation that I could not include papers which were in non-English because I can't read English. Okay, and translation of those papers was taking a lot of money. So I did not include papers which are non-English. You can say that. It's not that you cannot say this, but this is a bias in data collection and meta-analysis. This is a, should I say, it is a cause of bias. When I'm about to calculate the publication bias statistically right now, you will see that there will be some bias, some amount of bias, which will be reported. Now you might ask that, ma'am, we did so much of hard work and we removed all biases, and there were three authors who were collecting it, and then we showed it to an expert also. Now, how has this bias come? There will be a statistical value of bias, and you'll say, how has this bias come? I've not been biased in collecting data. You might say I've taken unpublished papers also. Then why is the bias coming? So I'm just telling you the reasons of that statistical bias. Despite the fact that you must have taken published papers and unpublished papers, language bias is something which even I as a researcher cannot remove. How will I study this paper which is written in Italian or in French? These are inevitable reasons of bias. And this is why that statistical bias, whatever that value will come, will show. Okay, so removing bias 100% is not possible for any meta-analyst, but there is a limit to which it should remain. That limit we are going to do. And that limited bias which has come, why has it come? I'm telling you the reasons. And even when you finish your meta-analytical paper and you write limitations of the study, you can write biases like language bias, because this is inevitable. It's nothing wrong in writing that I didn't take French papers because I can't read them. There's an availability bias also. So, the papers in Google Scholar or any research uh, database which are available to you, you tend to include those papers, and the papers whose PDF file is not available to you, you tend to remove it. Again, in the SLR paper that I showed you in the Prisma, he had categorically written that 23 papers I did not get the full text. He had written. And this is again inevitable. It could be a reason of bias, but if you show that there were thousands of research and all 1,000 papers you got a full PDF, it is more like a joke that you're telling to a reviewer. So please do make it a point to say that there was a set of papers for which I could not get full accessibility to the full PDF. And you can show it in Prisma also, and you can state it as a limitation in the end of the study, and you can justify that publication bias, whatever value comes, on the basis of this one factor also. There's a cost bias. So, if there's a paper which I have to buy from Emerald and which is somewhere around $78 vis-a-vis a paper which is $24, so I will go for papers which are $24. This is another cost bias. There's a familiarity bias. So I work on sustainable consumption, and this man that you see on the screen, Dr. Russell W. Belk, he's the father of sustainability, known as ethical consumption. He's the father of ethical consumption. It so happens that when I'm working on papers for meta-analysis, I get biased and collect more of Belk's paper. There's another person in this field called Whittle and Scott. There are other famous authors like Sheeran. So somehow what happens is, when I collect papers, I collect only papers from these famous authors, not me, any researcher would. So this is what we call a familiarity bias, because these papers are more familiar to me, these authors are more familiar to me, I tend to pick up those papers more than say an unpublished paper or a dissertation or a paper from a Scopus journal. Citation bias. When you start collecting papers, you tend to, collect papers which have a higher citation. This bias also should not be there in meta-analysis. Even if there's a paper which doesn't have a single citation, you're supposed to be including it in your data set. That is the exhaustive study. The most difficult thing in meta-analysis is not the statistical analysis, it is data collection. It's an exorbitant job. Yeah, so how do you judge the bias. Okay, so one way of judging the bias is the funnel plot. Let me show it to you in the meta-analytical sheet also. Yeah, so this is what we call a funnel plot. Again, this is more of an eyeball test, okay, not a concrete test, because over here you will see the 7 studies that I took. 4 studies are outside the funnel and 3 studies are inside the funnel. Okay, an ideal funnel looks something like this, where all the studies, what is a funnel plot? It is nothing but a graph plotted between the effect size at the x-axis and the standard error on the y-axis. And if you remember, when I was showing you the formula file, I had shown you a formula for standard error also. Okay, so funnel plot is a graph which is plotted of on effect size on the x-axis and the standard error on the y-axis. When we plot it, the standard error is an inverted axis. Inverted axis means it starts from 0.5 and goes to 0. Okay. So basically what happens is the studies which are having a lesser standard error are mostly on the top of the funnel. Okay. The funnel limits which you see the dotted line are nothing but the 95% confidence intervals calculated by the software. Now, what relevance does it have with the bias? So, if my publication bias is not there, all the studies which have been plotted, studies plotted are shown in the dots. All the studies which are plotted on this graph should lie inside the funnel. Okay. If they lie inside the funnel, I will say that there is no publication bias in my study. Although this is an ideal funnel, the funnel that you mostly get is something like this, where most of the studies fall inside the funnel, studies fall outside the funnel. So you can say, okay, subjectively you can say this doesn't have too much of a publication bias. It's acceptable publication bias, and you can report that our funnel was one in which all the studies were falling into the funnel. Vis-a-vis this, of course, this is, as I said, an eyeball test. So this is not a concrete test. So the best test which we have is, there are too many, but for the limited session that I have, I'll be able to complete only something called the fail and safe end test. Now, please try and understand what's the basis of the fail and safe end test. Then only can I take you to the meta essential sheet and show you the values. Fail and safe end test was given by Rosenthal 1979. His basic idea was, he said that a researcher gets so confused while collecting data that this bias, the first bias that I showed you, significant studies and non-significant studies, he gets biased towards reporting only significant studies. So when you're picking up a correlation value of, say, urge to buy and perceived enjoyment, you tend to pick up all those papers which have reported a significant correlation for these two studies. What do you do with the other studies which are non-significant? Even if you come across it, you chuck it into a drawer. So this, what Rosenthal said, was also called this bias problem that researchers have. Rosenthal called it the file drawer problem. He says that significant studies people include, and the non-significant studies they chuck into the drawer and close it, as if to say they were never there. Ye kabhi thi nahi. So they chuck it into the drawer and they close it. Now Rosenthal says that there is a statistical method of calculating these studies which have been chucked into the drawer, and he says that if these studies come out ever, even after you've done a meta-analysis, if these studies come out of the drawer ever, and these could be studies from all over the world, they will make your effect size equal to 0. So he says that if your effect size is say 3.4, suppose the consolidated combined effect size was 3.4. This is only because there are a few non-significant studies which you have chucked into the drawer. The day these studies come out, your effect size from 3.3 will become 0, which means your whole research will become 0. Now he has given a safe value of the number of studies that you can chuck into the drawer. And this safe value is 5k plus 10. So if your meta-analysis, k is the number of studies you've taken in meta-analysis. Suppose you have taken 50 studies in meta-analysis. Suppose you have taken 50 studies in meta-analysis. 5 into 50, which is 250, plus 10, which is 260. Your fail-safe n value should not be more than 260. In a way, we are saying that if 260 studies, safe value means this much value is safe. If 50 studies you have taken and there are another 260 studies which come out of the drawer, your effect size which you have found out for these 50 studies will remain 3.3. But if the value is more, say 280, which means now with these many studies coming out, your effect size will fall to 0. It's not a safe value. It's like saying, जब तक 270 स्टडीज आएंगी तब तक तो तुम सेफ हो, 270 से एक भी ऊपर आई तुम्हारा इफेक्ट साइज 0 हो जाएगा. That is what Rosenthal is saying. Now that is why safe n, and it is represented over here in the meta-analytical sheet. You can go absolutely towards the right and you will see something called a fail-safe n test. Okay, and there are so many fail-safe tests. Safe means this is the safe number, fail means you have crossed the safe number. That is why the name fail-safe. In this, there are many, Glasser and Olkin, Orwell, Fishers, etc. But the most famous and which is reported in papers is the fail-safe. So now look over here. The fail-safe value is 42. Okay, and it actually says that the ad hoc rule is true. Now, what is the ad hoc rule? The ad hoc rule is that ad hoc rule means that these many papers, if they come out, there will be a publication bias in your data set and your effect size will fall to 0. This statement is true, which means there is a publication bias in your studies. Okay, so that is what it means. In this case, it is true. Now, in case, okay, let me just for the sake of convenience, let me go to fixed model, but you don't do that. You do it only on the model that you are assuming in the paper. Just for the sake of demo, I am trying to do it on a fixed model. Now look at the study. Now it says in the random model, it says that the fail-safe n is turned to 946 because you know the fixed and random calculations are different. Now the fail-safe n value is 946. If suppose the benchmark for these 7 papers was 45, it is way ahead of that benchmark of 45. 946 papers will come out and then they will prove my effect size 0, so that will never happen. And thus he says that the ad hoc rule is false. What is the ad hoc rule? If these many papers come out, my effect size will fall to 0. That assumption is false. Thus, I have no publication bias in my paper. Okay, this has to be like a row. It has to be reported in all the bivariate relationships. Okay, there are quite a few publication bias which have been given in this sheet. There are many graphical methods and statistical methods of finding out publication bias. But the most common one I have completed, because this is what is seen mostly in the papers. Okay, so I'll stop here. I'm through with my session and we are now open to questions for the last 15 minutes. Any questions in the last 3 days that you have, please put it to me. The material I've already sent to the organizers. They'll be giving you all the papers. Yes, I had some, I see some hands up. So yes, Usha ma'am.
Good morning, ma'am.
Yeah, good.
Ma'am, in the paper you have shown urge to buy and perceived enjoyment. Then second session talks about urge to buy and perceive usefulness. Ma'am, by doing so, we will reach to a number where we will find urge to buy and other variable. It would be like 1 or 2 research papers only. So if the research papers are only 2, then also we are supposed to calculate the effect size for those 2 papers.
Yeah, so this is a good question. I unfortunately don't have a reference for this, but I have a reference which I have cited in one of my papers, where it says that for a meta-analytical study, at least 2 papers are required. Only 2 studies. So you can do it on 2 to 3 studies also. Next time maybe I'll carry that reference with me. I don't have the reference, but I've cited it in one of my papers.
Okay. Ma'am, can you just take me to that sample paper? I have one question in that also.
Yeah,
Theory of planned behavior research
yeah.
paper.
Give me 1 minute. So yes, yes.
Yes, ma'am. This particular table, ma'am, this table talks about association and K and number of factors. So in
Mm-hmm.
association, we have attitude and intention. Then
Mm-hmm.
second, SN and intention. So,
Mm-hmm.
ma'am, like if I talk about your paper, then first would be urge to buy and perceived enjoyment. Then second would be urge to buy and perceived usefulness, and
Yes.
so in that way.
Yeah. Urge to buy and scarcity. That was the third one, and I have such 8 factors.
So, ma'am, why they have taken it in a different manner? Like first is attitude and intention, then SN and intention, then PBC and intention. Why it is not like
I'll tell you. Because this
yes.
paper is based on planned behavior. So let me show you theory of planned behavior. They have taken up papers only from theory of planned behavior. And very common theory. So they have done a meta-analysis of a particular theory, and this is the theory. This is the theory. So here they are
Okay.
not doing factors impacting urge to buy, where I'm getting so many papers and different factors. They have only made a meta-analysis of all the papers which have taken theory of planned behavior. That is the reason they are again fiddling with only these variables: attitude, intention, subjective norm, intention, PBC behavior. They'll go around only these relationships.
Okay. Okay. Ma'am, actually, I'm doing a meta-analysis on impulse buying, antecedents on impulse buying. So when I will make this particular table, I will take like what all factors are responsible, like for say hedonic motivation and impulse buying. It could be pleasure and impulse buying. Impulse buying would always be there, na? Like that in that way, I
Impulse
should make
buying,
my table.
impulse buying will always be there, and your paper will be something like you'll have to make a model first. So I'll show you one of. I'll have to go to the mail for that, or do I? Give me 1 minute. I'll show you one paper. I'll show you how your model. So once you go through all the papers, you have to construct a theoretical model on the basis of what the papers are saying. So 777. I'll just show you what I'm trying to say. Uh, this is another paper which is in review. I'll just show you the. And I can't send you these papers. I'm so sorry. You can only see my published papers, and ideally my published papers are mostly on SEM, because till 2020 I was working on SEM only. It's in 2020 that I came into qualitative analysis and meta-analysis. So now my papers will get published. So now look at this paper. Okay. Now it says personal motives for anti-consumption, or should I say motivation of anti-consumption. Okay. Now you collected an SLR, you collected some 50 papers. Okay. and you found out that there were some antecedents. What is antecedents? The factors which impact anti-consumption. Okay,
Okay.
and
Okay.
on the right side you will see that there are some consequences. So because of anti-consumption something happened. You get my point? And you
Yes.
will
Yes.
get from the papers, you will get both correlation values. You will get papers where it will say that okay, product satisfaction led to anti-consumption. Okay, you will also get papers which will say, some papers which will give a correlation value and say anti-consumption affected self-interest. Suppose, okay, you have to
Okay.
make a model first, theoretical model, to say that okay, in the past 100 papers or 50 papers, these were the antecedents of anti-consumption and these were the consequences of anti-consumption. You get my point?
Okay. Yes, ma'am.
Right? Now, each of these arrows becomes a meta-analytical study. Each of these arrows becomes a row of this paper. Where am I? Where am I? This paper. Just a second. This paper. So these rows that you see, okay?
Okay. So for your paper, the rows would be 10.
Yes, yes, yes.
Okay. Okay. And ma'am, one more question, ma'am. After doing the Prisma for my paper, I have finally reached out to 21 papers. Now, as you discussed about the publication bias, actually, I have also taken papers unpublished, published one, which are in Q1 journals, which are not in good journals. So what my guide is now saying, he is saying you should only concentrate on papers which are from Q1 or Q2. So ma'am, if I do that, if I take journals, if I take papers which are from Q1 or Q2 journals, then my publication bias would increase. And I think we are supposed to, show this publication bias in my papers. We have to
Usha
report
ma'am,
this also, na?
I'll tell you. See, what happens is what is written in books and what happens in actual is a little different. It's true that even in meta-analytical papers, I showed you an A category paper that man has only taken. Okay, first of all, do we have a chat here? Do we have a chat here at all?
Chat.
Chat as in,
I didn't get.
is
Ma'am,
there a
chat
chat
box is
in
there.
this? Because I can't see it. I can't see a chat box. Okay. Anyways, in because I don't see a chat box over here. In any case, if any of you want to get to me for a meta-analytical paper or a questions or collaboration, you can just note down my email ID, which is justpreetkb. I'll probably do it on a Word document because I don't see a chat here. I just don't see a chat here. So yeah. So you can write to me if you are planning to make a meta-analytical paper.
Okay, ma'am.
This is my email ID. So first thing is please note down and please contact me here in case you are have any doubts in your meta-analytical paper even after the session. Now coming to
Okay,
your
ma'am.
question. What was your question, ma'am? Yeah. So 21 papers, ma'am. See, it is true that A category papers, the paper that I showed you, took only published papers. So that can happen. Your guide is not totally wrong. But the problem here is not that. The problem here is not only taking published here. The problem here is you've got only 21 papers. And if you don't
Okay.
have more than 50 papers, your research will not be published in an A category journal. My problem is that. My
Okay.
problem is that. So if
Ma'am, but just,
yeah,
ma'am, but there is one known name, Justin Paul, in terms of meta-analysis. I have seen one of his paper, and he has done meta-analysis on 8 papers only.
yes, ma'am. See, Justin Paul sir is a very known person. He getting a paper published and we getting a paper published, there's a lot of difference in that.
Yes, 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 very true,
Yeah.
ma'am.
So,
Yes, very
yeah.
true.
I mean, I go the hard work way. I mean, I have seen that I published, I had made a paper on 23. I'll tell you my real experience. Last year, I made a paper, it went around, it got rejected even in the B category journals. Now, that is when it really, A category, it gets rejected, it's okay. Or it goes in review and that gets rejected, it's okay. But B categories, if
Okay.
it gets rejected, means my paper is not even worth A. So then
Yes,
I
ma'am.
redid it. I took papers. First, I was taking only published. Then I started taking unpublished. I also expanded the word, ma'am. So where initially I was working only on religiosity, I worked on religion, religious belief, religious values. I expanded that also. That is also something that you can do. That is also that.
Okay.
When I expanded it, ma'am, my data set now that I've resubmitted it is 58 papers. And now finally, it has got through in the review process of Journal of Islamic Marketing, which is a B category journal. Now it has got through in review. I don't know how it fares, but I think I'll be able to get this through a B. I've still not cracked an A in meta-analysis.
Okay.
Maybe next year, but B, I think I'll be able to crack. C and Scopus I've cracked. The paper that I showed you is already getting published in
Okay.
23, so acceptance is there. But what I'm telling you is that the more the better. The more the better.
Okay, ma'am. Okay. And ma'am, you have explained the formulas as well manually, but ma'am, you have not explained like from which book I2 formula has been taken.
Borenstein. All formulas have been taken from Borenstein 2011. And
Okay.
when I sent you the material, I can also send you the book. So the book is there with me. I have a PDF of it. Let me show it to you. I think I have the PDF of it. Do I? Borenstein to be in B, best paper. I have two, three good papers also which are there in meta-analysis. Hunter and Smith, Borenstein. Hunter and Smith's book I have. Borenstein. Is this the one, Introduction to Meta-Analysis? Yes, this is Borenstein. So this is available as a PDF. This is available. It's called Introduction to Meta-Analysis. Borenstein, Hedges, Higgins, all people I've cited. So this is absolutely all formulas that I've taken are there in this book, and it's a very good book
Okay.
for beginners. Okay, you can refer to
Okay.
this book. It's there available on PDF.
Okay. Thank you so much, ma'am. Ma'am, I've already attended one session of yours earlier, and that is why I was keen interested in attending this session also. The earlier session was from Banarsi Das Institute.
Oh yes,
So
yes.
that was also very good, and this is also very good. And in this particular session, you have expanded so much, and I have learned so much. So thank you for that.
Please write to me. Maybe we could work on this paper together.
Okay, ma'am. Ma'am, in that essential sheets, we have, sub items also. Like you have explained, forest plot, then we have moderator analysis. So we have to do something on that also, moderate analysis and all these factors, subgroup analysis.
I'll tell you. So again, I'll have to open my mail and I'm putting in my YouTube channel. If you go to the YouTube channel, when I take a 5-day workshop, that is when I do all this. So if you go on my YouTube, you'll get in a very
Okay.
just uh, I, I just can't search it right. And go to my YouTube channel and you'll get here it is. Yes. So this is my YouTube channel link. Okay,
Okay.
and I don't have a chat, so probably the organizers can, give it to you. Um, Over there, I have all my FTPs. I mean, whenever an organization allows me to, uh, I generally find my yeah. So these are all my, so these are all on writing papers and SLR, whatever the topics I've taken, and if they allow me to, I put it up over here.
Okay.
This
Okay,
has my
ma'am.
5-day. Acha, I could have opened it over here also. Yeah. So this is my channel. Whichever FTPs I take and they allow me, I put it up here. So I have taken 5 days FTPs also, and I've put it up over here. So
Okay.
from introduction to research to qualitative research to systematic review and meta-analysis, you'll only find these topics. I don't generally take FTPs on other topics. It's only SLR meta-analysis and qualitative research primarily.
Okay, ma'am.
You'll find most of the things over here,
Okay, ma'am.
right?
Okay. Thank you so much, ma'am.
Thank you. Thank you. So I don't see any other hands raised. I hope uh, the session was of use to all of you. And I think now you all can, because
Morning,
you're,
ma'am. Can I ask?
yeah, yeah, Anjali ma'am. Yes, yes.
It was very informative session. I liked it. And as Usha said that she has attended two classes of yours, even I have attended two classes of yours, the same one. Ma'am, my question is that it's not a question, it's a help. I will ask for you that I am also doing a meta analysis, and my variables are financial literacy and financial behavior. So, if
Mhm.
in case I need your help, can I also write to you and
Please, please do write to me, ma'am. I'll give you my phone numbers. The moment you write to me, I'll send you my phone number, and then maybe we can make a WhatsApp group together of all
okay,
people who are working on meta-analysis so that we can
okay,
work together.
okay.
So
Thank you
if
so much, ma'am. Thank you so much.
I'll make a WhatsApp group of meta-analytical papers only so
Yes,
that
ma'am.
whenever the query comes from one, I can help the other. So we can do that. Sure, you can write to me at Jaspreet
Okay, ma'am.
at Native Mail. Even at LinkedIn, I'm there at as Jaspreet Kaur from Pearl Academy. So all of you can join the LinkedIn. Even at LinkedIn, sometimes I get messages of doubts, etc. So I do answer them.
Ma'am, one more thing that I am just seeing in the YouTube that I'm writing your name and I'm not finding your channel. Means any other
Ma'am,
thing you? Yes, ma'am.
yeah, Jaspreet Kaur and write SLR.
SLR. Okay,
Or
ma'am. Okay, ma'am.
just for meta-analysis or just Preet and qualitative analysis. Only then you'll find just Preet is a very,
Ma'am,
very
I
common.
got it. Yes, ma'am. I got it.
Yeah.
Yes. Thank you, ma'am.
Thank you. So I've given you my email ID. You'll be in contact with me through LinkedIn. Of course, YouTube videos are there. You can view that. So Sakshi ma'am, are you there?
Y
Yes.
yes, ma'am, I'm there.
Hi, ma'am. Hi. Yeah. So we can end the session, ma'am.
Yes, ma'am, we can. And Malti ma'am is there. Uh, uh, Ma'am, Malti ma'am is
I'm
our
there. I'm there. I'm
director,
there.
ma'am. Uh,
I'm there.
Okay.
yes, ma'am. Ma'am, please say some words about vote of thanks to ma'am.
I've been attending the sessions, and I think yesterday's session I did miss out, but nevertheless I can catch it up on the recording part. One uh, Kavita, I think you are on mute. Okay. So first of all, a big thank you to Jaspreet Kaur ma'am for making it seem so simple, because most of the times we say that research is not everyone's cup of tea. But I think you've made it everyone's cup of tea by explaining it so very comprehensively, and at the same time, an interest to actually start working on meta-analysis papers. I think when a resource person again generates that interest in all the participants, I think most of the job is done. So all the participants have had a lot of takeaways from the session, and earlier most of the concentration was on the SEM model. Now we moved on to qualitative research and meta-analysis. And this is in fact a great way also to take it forward, because research, review of literature is an essential part in any of the papers, researches that we talk about. So by doing so, I think most of us would be able to resolve a lot of issues. So thank you so very much, and thank you to both Kavita and Sakshi for organizing the session and taking the session through. We hope that there might have been a lot of takeaways for the participants also, and we hope to have this association in the times to come also. Online education, in fact, or online teaching has made it really easy for most of us to connect. Otherwise, coming down physically would have been difficult, but this is one platform, especially for the researchers, for the teachers and the academicians to connect all around the globe has become very easy. So I think let us take the maximum benefit out of it and connect more frequently to again progress in this area of research. Thank you so very much, ma'am. And thank you to all the participants who have been quite interactive and have also tried to get their queries answered. And as ma'am has said that she's always available for hand holding also, that's in fact a great initiative. So looking forward to a more engaging research oriented relationship, ma'am. So thank you so very much.
One thing which I really like from you is SEM. So I'll share a small joke with you. There was one
Mhm.
of my PhD scholar who came to me and she said, she didn't know the objective, nothing. She said, ma'am, SEM lagwa do. I said, beta, what's your research objective? Quantitative, qualitative? मैम वो मुझे कुछ नहीं पता आप आरओ मेरे से जो बनवा दो बस सेम लगवा दो सो that was the concentration of SEM. And when I saw meta analysis, ma'am, there wasn't a trainer of meta analysis in India. Indians weren't writing that many meta analytical papers. The only people who were writing was Justin Paul or Yogesh
Yeah.
Divekar, who are like from foreign universities, you know.
Yes.
So this was rightly said, it's an initiative so that people start writing. This is
No,
just
yeah. I think the initiative has been a great one, and you rightly said. And I would also want to share the same thing because when we have MBA students around us, most of the times they say that, ma'am, SPSS लगवा दो. ठीक है उनको लगता है we tell them that it's a tool and it will give you some result, but the point is that whether your data that you're getting in is actually again compatible for usage. पहले वो देखो आप SPSS ने SPSS लगा दिया तो फिर बहुत रिसर्च बहुत अच्छी हो गई है. This is the only so
yes.
that is now extended to STEM or the other things that we talk about.
People
So
have forgotten the research objective.
yeah,
They are on tools. Absolutely
that
on tools.
that and you have a lot of simple tools and you can do great analysis with those. And
I have seen ABTC B papers simply on regression.
yeah,
Simple regression.
uh,
Simple square I've seen papers published. And this is a wrong norm. Even I have gone through it in 2018 कि SEM निकाल लिया तो paper publish हो जाएगा. No,
that is true.
it's not.
That is
It's impossible.
may,
It's a
just like after going through this meta-analysis session, I thought we were doing narrative research and we thought we were doing a great job. Okay, so
yes.
now you understand how you go beyond that narrative literature and move.
Listen.
And these are steps. Till the time we do not again try to take those initiatives and learn certain things new, things again would be stagnated. So that initiative of yours needs a lot of appreciation. So thank you for taking that up. And again, as I've already said, Kavita and Sakshi had in fact put in that effort of contacting you and organizing the session. So we would also like others to extend their feedback. Some of them have done, but if some others want to, I think this is the right time because for a resource person or for a teacher, most of us are academicians. For a teacher, when they have done something so with all their heart and soul put in, a few words of appreciation again from all of us again would make their day. And I think there would not be any second thoughts to it. So this is the right time. I would again invite others in case they intend to express how they felt about the entire session. So you can go ahead and do 5 more or 10 more minutes. Do we have that time, Sakshi and Kavita?
Yes, sure, ma'am.
Yes.
Yeah. Okay. हम टीचर्स हैं या academicians या research scholars हैं, and most of us again normally have to be asked to stop rather than asked to talk.
Actually, उनका लास्ट वीकेंड है दिवाली से पहले तो सब कपड़े शपड़े पहन के बैठे होंगे और एकदम से शायद
Okay, कोई बात नहीं है. I think
that's what I think on the session also. I thought it's the last day before Diwali, the last weekend before Diwali, so I can understand people are rushing around.
yeah, I completely understand.
They'll be free.
Yeah, that's fine. Okay, so I think you guys can wind up the session now. Hmm.
Yes,
Uh,
now I'd like to request all the participants to switch on their cameras so that we can have a group photograph. I know that's a difficult task. That's why I informed in advance in our WhatsApp group. Just for a minute, it's a request to all to switch on their cameras and then we'll wind up.
yes, Kavita ma'am, we have taken
Okay.
pictures. Okay.
Okay.
Thank
Thank
you
you
so
so
much,
much,
everyone.
everyone.
Thank you, ma'am.
Or maybe.
Thank you,
Thank
Jaspreet ma'am. Thank you, Malti ma'am, and thank you all the participants. Thank you so much for joining the session.
Thank you. Goodbye.
Thank you, ma'am.